This is an introduction to Module 9 from Making Spatial Decisions using GIS and remote sensing, and it is going to cover water. So we'll be working in an area in Texas, and you can see the state of Texas here with some counties, and there are some reservoirs that are highlighted in red. So that's what you will be analyzing for this module. So here's a tip on finding the 3 biggest reservoirs. You may know how to do this in ArcGIS, or it might be new for you. If you right-click on reservoirs in the layers for your table of contents and then open up your attribute table as shown here. If you sort ascending, you can highlight the top 3 and you'll notice that the table records are highlighted, as are the reservoirs on your map layout in light blue. So when you are looking at perfect circles in this lab, please note that these are a particular type of land cover, and you may or may not know that these are agricultural fields, and they are designed this way because of the engineering of the sprinkler systems that water the crops. When you're looking for dominant types of land covers, here's a tip: is look at the counts that you can find in the Symbology tab. This is in your layer of properties, and if you right click on the title of the layer in the table of contents, open up layer properties, and then look at the Symbology tab, you will notice that there are polygons or colors. There's a label in this example, and then there's a count. So you can look and see which one has the highest count. That is a dominant type of land cover. That is a quantitative way to do this rather than a qualitative, where you would just be assessing what you could see visually. So we're going to look at using the slice tool, and it's a raster tool that reclassifies the range of values of the input cells into zones of equal interval, equal area, or natural breaks. So you can find the slice tool by going to your geoprocessing menu option and then searching for tools and entering in slice. And you want to use the one for spatial analyst. So when we classify data, there's 3 different types or ways that you can use the slice tool. With equal interval, it's determining the range of input values and divides the range into a specified number of output zones. Each zone of the sliced output raster has the potential of having input cell values that have the same range from the extremes. With equal area, you're looking at a specified number of output zones, with each zone having a similar number of cells. Each zone represents a similar amount of area. And then natural breaks is specifying the classes based on natural groupings that are inherent in your data. Breakpoints or natural breaking points are identified by choosing the class breaks that best group similar values and maximize differences between classes. And the cell values are divided into classes whose boundaries are set when there are relatively big jumps in the data values. So these images should help you understand equal interval and natural breaks. So these are the same counties that you see in your blue shades at the top, and then the classification on the left is equal interval, and it's just dividing the range of attribute values into equal sized subranges. So if you look at those blue lines, they are all equally spaced apart. And then on the right, it's the same data set, and it is now broken up into natural breaks, and you can see that the data is classified according to where there are relatively big differences in the data values. You're going to be doing pixel counts in masks for comparisons of all reservoirs. And again, you can use your geoprocessing search for tools to find extract by mask. this is an example of some of the findings that you will get. You may get slightly different results, but they should be pretty close, especially in terms of the percentages. So just putting this up here for your reference to make sure that you can look at this and check to see if you're on the right track. And that concludes Module 9 Introduction. Thank you.